In this section, we're going to learn about double angle identities. So these are those double angle identities that you can add to your notes. But you do have three options here for cosine. So sometimes you can use any of these three, depending on what we're doing at the particular time. But sometimes you'll definitely want to choose one of those over the other one. But there are three different options for cosine, so you need to copy those down. All right, so first problem, we know that cosine A is equal to -4/5 and angle A is in the second quadrant. So we're going to use those identities to find cosine 2A, tangent 2A, and cosecant 2A. All right, so similar to what we had done with the sum and difference identities, since I'm giving you cosine, and cosine is x over r, so that's going to mean that for this particular problem, that x is equal to -4, and we will need to come up with y, and r is equal to 5. Now, this is one of those Pythagorean triples, the 3, 4, 5. Again, if it's not one of those, you can always use your Pythagorean theorem to come up with the missing value. You do have an option of positive or -3 for y, but since this is in the second quadrant, your y value would have to be positive, so we'll go with +3. Now, from that, I can come up with sine of angle A. That would be y over r. So that's 3 over 5. And then cosine of angle A. Well, of course, cosine was the one that was given to us. So let's just do tangent. So tangent of angle A would be y over x. So that would be 3 over -4. Okay, so the first that I've asked you to find is going to be cosine of 2A. Now, this is one of the situations where you can pick any of the three that you want to, because we do know sine and cosine. So you could use this one because you know sine and cosine, or you can use this one because you know cosine, or you can use this one because you know sine. So this one, just pick whichever one you want to use. I'll just use the first one that says cosine squared A minus sine squared A. All right, so we know that cosine's -4/5, so I'll have -4/5, but I need to square it, minus sine squared, so we have found that sine is 3/5, and I need to square that. So now just basic math at this point. So square each of those fractions, so we're going to have 16 over 25 minus 9 over 25. So of course 16 minus 9 is going to give us 7. So 7 over 25 is the value that we're looking for. All right, next is tangent 2A. Okay, so your identity for tangent 2A is 2 times tangent A divided by 1 minus tangent squared A. Okay, so we have found our value back up here for tangent A. So we'll have 2 times -3/4 divided by 1 minus -3/4 squared. So again, now at this time, just basic arithmetic. So multiply, we get -6 over 4. Of course, you could reduce if you wanted. Then you would have 1 minus 9/16. Okay, I'm going to go ahead and reduce this, so I have -3/2. And then go ahead and do the 1 minus 9/16. So that will give us 7/16. Now simplifying this, we will end up with, let's see, that's -48 over 14, which we can reduce by 7. Or no, actually, I guess just reduced by 2. So negative 24 over 7. So there's your value for that. Now, the last piece of information I asked you to find was cosecant. Now, I did not list a double angle identity for cosecant, but you do have the double angle identity for sine, so you'll use this and then just take your answer and flip it, do the reciprocal. All right, so first of all, we're going to find sine 2a. So that's 2 times sine A times cosine A. All right, so sine A was 3/5. Cosine A was negative 4/5. Okay, so just do the multiplication there, and we will have negative 24 over 25. So therefore, that means that cosecant 2a would be negative 25 over 24. So, of course, I just asked for those three, but you could be asked for any of the double angle identities. Once you know sine, cosine, and tangent for that particular angle, then you could find any of them. Okay, next. All right, so what we're going to do here is actually just use the identities in reverse order. All right, so if you look at what you have here, 2 times cosine squared 15 degrees minus 1, that resembles, I can pull it over here to the side, that resembles this one, okay? So for this particular problem, what you have in the position here of A is going to be the 15 degrees, okay? So like I said, same identity, basically we're just using it in reverse order. Okay, so this is A. So that means that I could write this then as cosine of 2 times A, which would give me cosine of 30 degrees, 2 times 15 degrees, but 30 degrees is one of those values from your table, and cosine 30 degrees is square root 3 over 2. So there's your answer. Okay, next one. The one that we have here, of course, fits the identity for tangent to A. So again, what we have for A on this example is going to be 75 degrees. So again, just using it in reverse order, this would be equal to tangent of 2 times 75. So that would be tangent of 150 degrees. Now, 150 is not one of those we know directly off of our table, but the reference angle for 150 degrees is 30 degrees. So we can use that to help us out here. So we'll replace 150 degrees with the 30 degrees. Now, we do have to decide positive or negative, and that's based on the angle that we're actually trying to get the value for. So 150 degrees is in the second quadrant, and tangent's going to be negative in the second quadrant. So then straight off of your values, tangent 30 degrees is 1 over square root 3. So that would be negative 1 over square root 3.